The traditional methods for detection are typically using PCR or polymerase chain reaction, but it does have limitations, mainly in how much time it takes. So what we're looking at here is actually a laser interrogation technique called Raman. So what is Raman? When you throw photons at a molecule, most of them come out of the molecule at the same energy level, and that's called Rayleigh scatterings. But that doesn't always happen. Sometimes the photon will interact with the molecular structure and different ligands and functional groups in such a way that it either picks up or loses some energy based on that structure. And what we have here are actually some antibody samples from the SARS COVID-19 protein. So let's take a look and see how well we can do at detecting this using the typical Raman SERS setup. So what we're looking at here today is a typical 785 nanometer Raman setup tuned for our SERS substrates. This form factor uses gold nanoparticles embedded into a proprietary quartz matrix. They're very low cost, so they're meant to be consumables and very powerful in their ability to bring up Raman signals that are otherwise completely undetectable. The spectrometer we're using here is the QE Pro high performance spectrometer, and this is a high resolution spectrometer with very good sensitivity for low light scenarios such as Raman emissions, which are very low probability types of emissions. All we're going to do is show you how easy it is to take a sample background scan of our SERS substrate and then apply the analyte and get a meaningful reading from that sample. So this is ultra pure water. So we're just taking about 5 microliters of this, and we're going to place it onto our SERS substrate. We're going to stick that right into the holder. We're going to see some emissions here. So if we click on this camera icon, it's going to freeze that in place of what we're looking at now. Let's do that here on this one as well. So we know what this looks like now, what to expect without our analyte present. So let's go ahead and apply some of our COVID antibody on there. We're going to take another 5 microliters. Let's stick that right on the substrate there. So now, with this protein present, and now we're seeing, relative to the original signal, some depressions and some amplifications. These peaks that were present both before and after, those are inherent to some of the proprietary components we put into these substrates to help with that enhancement. We can see then that we're getting an amplification of the signal right in this region, and we're getting some depressions down in other regions here. I'm actually seeing a good, nice peak formation right there, which we saw in some prior COVID-related samples. So this is something that may very well hold true and would be an important part of a measurement for COVID detection.